So you're saying, well, it sounds like there's a lot of information that could be used in zone metering, so why isn't it perfect? So there are actually several examples of when this can actually fail. So snow, for example. Snow will almost always trick a camera's metering system, and you'll have some problems there. If something is backlit, or sunrises, sunsets, if any very heavy change between light and dark regions of a scene, you will probably have some problems with. Dark jackets, dark objects, objects with lots of shadows will tend to give metering problems, and you'll have to try to combat this. And in fact, a scene like this, where you have not only white snow, but also people wearing dark jackets, it can actually be double trouble. It can actually be very difficult to try to get everything properly exposed. So if you remember, if you have a situation like this, you could use bracketing, for example, but that's sort of silly in this case, where obviously things and people are in motion, and it's going to be difficult. But to make this even more concrete, so what is actually happening when metering fails? Let's say you take a picture of a scene that's primarily snow. And so if you take a look on the left side, this is without any exposure compensation. And so there's this concept of exposure compensation, where you can tell the camera, okay, I think you're going to be wrong about exposing this scene, so I'm going to tell you to change your exposure values either some number of stops brighter or some number of stops darker. And so if you take a photo that looks like this, then you might realize, okay, I have to actually adjust the exposure compensation on this camera to properly expose the image within it. And so if you notice, this actually looks very, very gray, very, very similar to what I described before of the camera trying to make the whole scene sort of this middle of the road gray, because that's what happens in most situations. However, for snow, for photos of snow areas, that's going to be pretty much incorrect, and we need to dial in some additional or some positive exposure compensation in order to tell it that the scene is actually much brighter than the camera thinks it is. So if you take a scene that looks like this, and actually if you take a photo of a scene and you look at it on the LCD screen of your camera, it may actually be somewhat difficult to tell if this is under or overexposed, so you might actually have to use a quantitative tool that can help you figure it out, and that's called the histogram. We'll go into a lot of detail about that in a couple of lectures, but just realize that there is a way, even if you're outside and looking on this little tiny screen on your camera, there is a way for you to tell if the exposure is incorrect or not correct, or is incorrect or correct. And so if you look at the histogram, you might realize, okay, this actually looks some number of stops too dark. So you might actually, and this is where experience really comes into play, because you might say, okay, well, this looks one stop darker, and so you try to increase the stops by one. So if we take a look at the exposure values that the camera decided to use, on the left we have a photo that was taken at 1/80th of a second at ISO 400 and an F number of 2.8. There was no exposure compensation at the time, so that was just the exposure values that the camera decided to use. But on the right, I said, okay, well, there's a lot of snow in this picture, so I need to increase the exposure compensation by about 1.3 stops, so about 1 1/3. So now what the camera did was that it used 1/80th of a second at ISO 800, so I got one additional stop there, and at f 2.5, at an f number of 2.5. So I gained that 1.3 additional stops by making the aperture 1/3 of a stop larger and by increasing the sensitivity by about 1 stop. So if you really need to keep, remember, this is where all of your knowledge now of exposure values can come into play. If you're in a certain metering, or if you're in a certain exposure mode, and you need to keep some value constant, so for example, shutter speed, you can modify those other two values, or you can have the camera modify the other two values to try to do this. Now, exposure compensation is usually used for modes where the camera is trying to figure out either one or more of the exposure values for you, because that's where it makes sense, is that if it's trying to calculate some number of values for you and you know that it's going to be wrong, then you can use exposure compensation to try to force an overexposure. However, the same thing can happen other times if you have a scene that's way too bright. So maybe somebody, so in that previous example that I mentioned where I'm wearing a very dark shirt, and it's going to try to make the scene a little bit too bright. you can decrease the exposure compensation, or you can put negative exposure compensation in to try to tell it to be darker. And so sometimes your camera will show you like a little graph with a little bar underneath of how much exposure compensation you're putting in. Just realize that if you're putting in, and this was confusing for me at first too, so don't worry if it is for you as well. But if you dial in a positive amount, that means you want the camera to make the scene brighter. So you're telling the camera to be brighter by putting in a positive amount of exposure compensation, and you're telling the camera conversely to be darker to take the scene maybe at a faster shutter speed, for example, by putting in negative exposure compensation. Now all of these, these sorts of capabilities of the camera, using the zone metering and all of this stuff, we said that there is a variety of ways that the camera could modify, let's say, the Sunny 16 rule in order to figure out what values it should actually be using. But it can actually, but as you saw, we have 3 values that we can modify. So if we have the Sunny 16 rule, we suddenly take a picture inside and we know it's too dark. How does the camera know which of those 3 values to modify? And that is what some of these metering modes try to do for you. So, a lot of cameras have a variety of modes in addition to sort of an auto mode where it does everything for you. And you can see that there's a bunch there that the camera will try to use. So going counterclockwise from here, we have a portrait mode, for example. We have landscape mode, sports mode, close-up or a macro mode, or a night portrait mode. And some newer cameras have even more of these useless modes, like self-portrait, party, candlelight, and I'm just listing some of the ones that comes from that camera that you can rent from 53 Church Street. I'm just using it as an example for what companies shouldn't do, I think, so that you can also have self-portrait mode, party mode, candlelight mode, sunset mode, fireworks mode, beach mode, snow mode. Like, come on, really? Do we really need all of that stuff? Well, if we look at all of these logically, you'll realize that all of these things are very easily replicated by yourself, just using one of these manual modes. And by doing so, you have a lot more control over the camera. So let's take a look at portrait mode, for example. So in a portrait, what do you generally want? So when you've seen professional level portraits, it's a photo of a person, and that's it, right? They try to isolate the person or the subject from everything else. So you might then want to have a lot of background blur to try to isolate the subject of the person away from the background, especially if it's a busy street or somewhere that's not exactly a studio. So with this in mind, let's say that we have it set to portrait mode here. So what might the camera try to do when taking a photo in portrait mode? Right, exactly. So based on how bright it thinks the scene is, it will open up the aperture as much as it can, so it'll make the F number be as low as it possibly can, and then it will adjust the other 2 values as necessary. So then if it's a very wide open aperture, it's letting in a lot of light, and that means you can get a fast shutter speed. That's generally a good thing. Now, landscape mode might be the opposite. You might have a lot in the scene that you want to get into focus. So you might have what then for this? Yes? Yeah, so a small aperture or a large F number, you will get then a lot or a large depth of field, and you'll try to get as much into the scene as possible. So what I'm referring to here is how the camera might bias one or more of these settings when trying to calculate the final exposure values that it can. So it might use a relatively high F number, like F11 or F16 if it's possible to use when in landscape mode. So how about sports? Yeah, the highest shutter speed it possibly can. So it's going to make that as high as it possibly can, maybe increase the ISO a little bit, maybe open the aperture as much as it possibly can there as well. So close up, that may be difficult to visualize, but when you're taking macro photos, the depth of field actually becomes much narrower than you are used to. So it might be very similar to landscape mode, where it would try to make the depth of field large by increasing the F number, for example. Night portrait, this one could be a little bit tough. It might try to use flash, for example. It might have to use a very long shutter speed to try to get some objects to actually become exposed in a photo, and it really depends on that one, I think, on what you're talking about, whether it's a night mode or a night portrait mode, on how it would react in those cases. And so those are just sort of the more popular ones. And so now that you are getting a grasp of these things, hopefully now you can stop relying on these modes quite so much. And in fact, cameras, as cameras get more expensive, you'll notice that they actually have fewer metering modes. So this is the metering dial from a now ancient 5D, Canon 5D, and they don't have any of these other modes. They don't have portrait mode, they don't have landscape mode, etc. They assume that the person that is purchasing this camera knows how to use these sort of more manual modes to try to take a photo with the particular effects that they want to use. So there's a couple of things that's interesting about this. First of all, they have a green box, which is sort of a completely automatic mode, which is still useful if, for example, you are on vacation and you trust someone enough to take a photo of you in front of a particular location, then it might be useful to set your camera to that sort of automatic mode for them. But going counterclockwise from there, you'll see that we have some other manual modes as well. So we have a P mode, what's called a program mode. What this will do is it basically allows you to set the ISO to whatever ISO you want, and then it will try to calculate aperture and shutter speed for you. So and you can usually adjust one of the dials behind your camera to either increase the shutter speed and decrease the f number at the same time, or do the converse depending on what you want. Some people prefer this mode, but I think what are some of the more useful modes, at least for myself, are the next two. So TV, or shutter priority, and AV, or aperture priority. And in these modes, what you get to do are set the ISO and the shutter speed, or the aperture, respectively, and then the camera will figure out the rest. So for TV mode, so shutter speed priority, for example, you might say, okay, well, I have to take a photo that's, reasonably fast. So I'm in a sports situation. I need to take a reasonably fast photo. So I'll set a relatively high shutter speed with the shutter speed priority mode. I'll set maybe a relatively high ISO as well, so that I can get a pretty decent aperture, and then it will automatically calculate the aperture, or the f number, for you. So aperture priority mode does basically the same thing, but for the aperture, you get to set the f number that you want to use. So you could say, okay, I want a lot of depth of field, I want a little bit of depth of field, and then you set the ISO, and then it calculates the shutter speed that it can use for you. And for what it's worth, of all of these modes, I tend to use the aperture priority the most. And the reason for that, even though the shutter speed priority might actually sound somewhat useful, it's that the actual range of the f number is somewhat low compared to the range of shutter speed. So your lens might be capable of, say, f2.8 to about f11, and that's just not that many stops when compared to the wide range of shutter speeds that's available. So it's generally, you generally have to do a little bit less futzing with the camera if you are using the aperture priority mode. Then, of course, the M is the fully manual mode. You get to set all three of these exposure values by yourself. Sometimes your camera will give you a little bit of a graph that will try to help you figure out if it thinks you are properly or improperly exposing your scene. And in fact, I highly recommend that if you are not familiar with a lot of these exposure values, that you take a number of photos in the manual mode. It will really give you a new appreciation for all of the technology behind a camera. The B in this case is a bulb mode. So if you remember, I mentioned that if you there's a certain mode that if you hold down the shutter button, it will keep the shutter open for that long, for however long you hold it. That is the bulb mode. And in this case, there's a dedicated metering mode for it. Sometimes you have to go into the menus or into the manual mode and adjust some settings to get that yourself. But that will also be really, really useful in particularly dark areas. And this last one, this C mode, that's probably just a custom mode that's available through the menus of this particular camera. All right, so we've talked about the three major ways that you can adjust the settings on the camera to affect the outcome of your photo. So we talked about the shutter speed, the sensitivity, and the aperture. But one of the things we haven't really talked about is changing the amount of available light that exists within a scene. So maybe the scene is a little bit dark and you need to increase some light. Or maybe the scene is a little bit too bright and you need to try to decrease the amount of light there. And so for this last example, remember that I mentioned you could use like a large reflector or even a large poster board or a large sheet of paper, just something to try to block out light if you have a small area. But where it can become problematic is if you're taking a picture of a large scene, so maybe a large landscape, for example. I bet you don't have a sheet of paper that's large enough to cover an entire mountaintop, for example. Now, I'm a big fan of taking photos in natural light because I think there's something very organic and very neat about the way that those photos look, particularly indoors. It's not something that you see very frequently, except maybe more recently as cameras get a little bit better with their sensitivity and can have higher ISOs with not such ridiculous noise. But even just a couple of years ago, and still to this day, it's really hard to find good photos of natural light that are taken indoors because it's very limiting. There's not a lot of light available to you. What can be, in fact, to go off on a very small tangent, for years I had this stigma against using flash, so against using additional levels of light, because it seemed very difficult at the time to get it to look natural, to get it to look like it belonged in the photo and didn't look like a very typical flash photo where you see the person's face that's completely blown out with exposure, and then everything behind them is completely dark because the flash can't reach. And there's also a variety of reasons why you might want to use natural light rather than using flash. And so, for example, sports. If you are in an indoor sports arena, for example, and you're trying to take photos of a team or of a sporting event that's happening indoors, using a flash can be distracting for the players. It can be difficult for them to concentrate, particularly if the flash is near the near where they are playing. So you might not always have this sort of luxury available to you. But as you can tell, one of the things that is important to us as photographers is being able to enhance the amount of available light and to use a flash in order to get more light in the scene. So this image here is a very typical example of a flash unit that's built into a camera. So you could have a Nikon or a Canon camera that has a flash that basically just pops up, and it lets you use, and basically will take a flash photo for you. And so these units they're okay. They're decently powered, but they're not going to do a whole lot of favors. There's a number of things that's working against you, and reasons why you perhaps should not be using the flash that's available here. But on the converse side, of course, there's a number of good reasons why you would want to. So if I were to take a photo, and if I took that photo with flash, what's sort of the typical scenario? How does that photo typically look in terms of the exposure?
Well, even but somewhat flat.
Even but flat. So portions of the image, the portions where the flash properly exposes, those look properly exposed. But they're also, very flat. The lighting is somewhat flat, but it is also somewhat harsh at the same time. But very shortly before that subject, so if the subject was here and they're properly exposed, very shortly before that subject and very shortly after that subject, you get exposure problems. So behind the subject, it's going to be too dark. It's going to definitely be overexposed, or rather underexposed. And before the subject, if you have any objects within the photo, it's going to be overexposed. And so this is something that we as photographers have to battle with when we are talking about using a flash. And in fact, I don't mean to scare you with a little bit of math, but the reason that this happens is for this property called the inverse square law. So if we have some source of light, so whether it be the sun, a flash unit, a flashlight, it doesn't really matter what it is. Let's say that it's just here in the center, S, or right here. So these two are basically the same thing. Now, that light, as you know, just emanates everywhere. So it expands in every possible direction through space. And so what this means is that as you get farther and farther away from the thing that is producing light, you are getting fewer photons, because as you're getting farther away from it, those photons are splitting farther and farther apart, and so your eyes are only going to see a certain amount of photons. And so to talk about this in more scientifically or more rigidly, we have this inverse square law. So every time you double the distance away, so let's say that right now I am about a meter, about 3 feet away from the flash unit, but now let's say that I go back another meter, I've now doubled my distance, I now am getting 1/4 the amount of light. So by doubling my distance, I get 1/4 the amount of light. And so that's where this inverse square law comes into play. Every time you double it, you are getting 1/4 the amount of light. Or every time you triple it, you have to square the number here. So every time you triple it, you're getting 1/9 the amount of light that was available at the source. So very, very quickly, you are getting much, much less light that was emanating from the source available to you for any reason. So whether you are using it to view or whether you're using it to take a photograph of, every time you double the distance, you're getting much, much less light. You're getting 2 stops less light every time you double the distance to make it more concrete. And so that's a lot less light that you have to deal with. And as we've been talking about, cameras are very, very sensitive to the range that they can detect, the range of photons that they can detect. There's a certain amount of photons that's definitely too little, and there's a certain amount of photons that's definitely too much. And if it's more than that, it's going to appear overexposed, it's going to appear all white. If it's less than that range, it's going to appear too dark. And because of this inverse square law, that's precisely what's happening with these flash photos. So if you're a certain distance away and I'm properly exposed here, you can imagine that very quickly before and very quickly after me, in terms of the distance from the camera, am I going to have too much or too little light available to properly expose an object. So to come back to these diagrams here, if we imagine that this source is giving out, just to make this hopefully a little bit more concrete, if we imagine that this source is giving out exactly 4 photons of light, which isn't a lot, but it's just to give you an idea so you can use these lines as sort of a guide. Now, if I am a certain distance away, and let's say that my eye is maybe that large, for example, now I can see those 4 photons. But as I get farther away, those photons are splitting farther and farther, because as they emanate from the source, they're getting farther and farther apart. So that means that I need to have a larger area in order to detect those same 4 photons. And in fact, you notice that now my eye only gets 1 of those photons, whereas before it got all 4. And the same thing just sort of happens as you propagate farther and farther away. So as a distance, and what they're calling the distances r here, as the distance r increases, the intensity of the light decreases by r squared. And that's divided by r squared. So that's all the inverse square law says, is that by increasing the distance, you are decreasing the intensity of that light by that distance squared. And so this is a big problem for us in terms of flashes. And so there's yet another equation that I have to introduce to you that a lot of flash manufacturers use to try to tell you how powerful their flashes are. So if you can imagine that there is a particular range, so let's say this flash is powerful enough to properly illuminate something all the way to maybe 3 feet away, for example. So even though it's dispersing a lot, something 3 feet away can still be properly exposed. There is a way that these flash manufacturers try to tell you how powerful they are. And that is using something called the guide number.